Hello, everyone, and welcome to today's live broadcast, Sampling for Cannabis Testing, presented by Shawn Kassner, a senior scientist at Neptune and Company. I am Judy O'Rourke of LabRoots, and I'll be your moderator for today's event. We're delighted to bring you this educational web seminar presented by LabRoots. LabRoots is the leading scientific social networking website and producer of educational virtual events and webinars. Before we begin, I would like to remind everyone this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. Just click on the Ask a Question box located on the far left of your screen and type your questions into the drop-down box that appears on the screen. We'll answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, please click on the Help Desk button located in the promotional board at the bottom center of your screen, or use the Ask a Question box to let us know that you're having a problem. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located in the top right corner of the presentation window and follow the process to obtain your credits. Please join me in welcoming Shawn Kassner. I will now turn the presentation over to him.
Well, welcome everyone. Today we're going to be talking about cannabis sampling and the importance of sampling and the role of sampling within the community, and the importance of sampling as it pertains to testing. So today what we're going to go through is we're going to go ahead and start with the role of sampling within the marijuana industry, what the ethics of sampling are, the standard operating procedures. We're going to go do a quick review of what those are. Then we're going to look at sampling strategies for flower, concentrates, and edibles, and then talk about laboratory coordination. So why are we sampling? Well, we're sampling because testing is required. If we want to look at the reasons why we're testing, as far as regulatory compliance, product safety, and manufacturing information. So the regulatory testing goals are, we're looking for product testing, for product safety, for microbiology constituents, whether those be salmonella, whether it be E. coli, or Campylobacter, or Listeria, the organisms we're seeing, or different toxins for mycotoxins. As far as residual solvents for concentrates, and then the different pesticides that are out there. But for most of the states, there are all different pesticide lists throughout the states, so that there's a large variety, a number of them to worry about, and the different analyses, as well as metals analyses. The other reason why the regulatory goals for testing are to understand and make sure that we have accurate labeling for dosage for different medical marijuana, the regulatory concentration limits for adult use, and then just for overall product safety concerns. But the goal for the community, as far as the cultivator and manufacturer goals are, for product safety. Do we meet regulatory compliance for our products? And we care about our customers, so we want to make sure we're putting out a good quality product that is safe for people to consume. And then there's product liability. This is something we don't talk about very often. Just because we have products, therefore we do have product liability. And that's something that, as the industry matures, we're going to be worrying about and talking about as we move forward. We also want to make sure that we're meeting regulatory requirements for labeling, making sure we have the right information on there as far as potency goes, and moving forward. We care about our customers. We want to provide our customers the most accurate information as far as what potency levels are and cannabinoid levels are. We also want to know for marketing purposes. We want to know what our cannabinoid levels are. We want to know what the cleanliness of our product are, and that does feed into marketing. We'll just put it out there and be honest about it. And then for product manufacturing, we need to know what the potency levels are. So when we start using concentrates to manufacture other products, we take that into account. And so it's a quality control check for that. And we also want to ensure there isn't any microbial contamination in there, or that we're off to remediate that microbial contamination. So the role of sampling really is, where does it fit? How does it work within the realm of the community? And basically, you are right here. You're right in between cultivation and growing and extracting, and then moving samples off to the laboratory. It fits into the cycle of life for a particular product. Whether you start at the laboratory world and pick out from testing, which goes into the state regulatory databases like Metric, and then goes on to product labels. And so the whole product process moves around in this circle that we've got demonstrated here. So why is sampling important? Samples represent the harvest batch or your production batch that are about to be sold, whether it be flowers or concentrates or infused products. All the information that the laboratory provides us from the analytical work they do is based on the samples that you take. So all of that data represents what that product is. And what we want to make sure is that data is as accurate as possible. That data is also used for manufacturing of edibles and non-edibles. So that is why everything is important. All the information about how you use the sample, who's using the sample, how it's manufactured using the manufacturing process, all comes from the testing, which is based on those samples. Any adulteration or any bias to your sampling technique or poor homogenation will impact the data generated by the laboratory. So any type of adulteration is putting your sample in a microwave or cutting down the microbial contaminants, all are going to impact the testing. And there is no amount of analytical testing that can fix inappropriate or bad sampling. It's just you're not able to recover from that. So when do we sample? Sample probably the best place to sample is at the very end of the process, just before your final product goes off into the public for sale. So for flower, it's sampling just after the drying process, but before the final packaging. And for edibles and non-edibles, what happens is, and for concentrates, it's whatever the final form is before it goes off to the customer as well. So typically this is done to further perform more homogeneity testing so that the products that are offered, such as brownies and cookies and things, can be tested for homogeneity and making sure that the sample, the cannabinoid concentration is evenly distributed throughout that particular sample. Concentrates are prior to use in manufacturing or as a final product. That depends on what the state requirements are, as well as the business requirements, and then where the form in which everything is being used as far as the concentrate goes. Because we have liquid concentrates as far as tinctures go, we have more solid concentrates such as shatter, waxes, and bubble hash. So those are the things that we look at. For sampling for non-edibles, it's after the product is in its final form. So we have lotions and different other products like that we look at as far as being in its final form before we move it out. Again, done to ensure that there's homogeneity within the product, that the cannabinoids are spread evenly through the product or for dosing purposes. So we have to understand that sampling contributes the greatest amount of error to the testing program. Poor sampling that is inconsistent leads to laboratory results that are inconsistent. They could also lead to cross-contamination if we get sloppy. And if you don't homogenize the samples well, then we don't have good understanding of what's going on with the homogeneity of your product. So therefore, you might fail your sample there as well. All of these resources there that gets propagated by the laboratory, because what they do is they take your sample, that you've collected, and then subsample them and subsample those into further analyses, whether it be for potency, whether it be for microbiology purposes, or whether it be for pesticides or metals or whatever the testing is that you're having done at the time. So let's talk about sampling ethics, because this is where we've seen some of the more important things going on within the industry. So what is that? What does it mean to be ethical? Well, ethical means pertaining to or dealing with the principles of morality, pertaining to what is right and what is wrong in conduct. This means conducting yourself in a manner that is honest, transparent, and appropriate to the task. So basically what that means to the individual doing the sampling, whether you work for a sampling company or you work for a facility or you're working for a laboratory who's doing the sampling, is following the written procedures that you were trained to, following your SOPs, your standard operating procedures, performing the tasks that are supportive to your company goals or to the goals of the laboratory, which is getting the best, most representative data for the products that you're sampling. And make sure that those products are truly representative of the product that the company has produced or that your company has produced if you're actually doing the work yourselves. Again, sampling is the most critical point in the testing process. It's at the very beginning of the testing process. So samplers are responsible for collecting representative samples, ensuring that there's no adulteration, ensuring that samples are collected with an aseptic technique or an aseptic manner. Samples that are collected represent what the product is being sold to the public. So whatever the sampling collection process is and what the testing process is, that is what that information is what's moving forward to the public. So again, any errors or biases in the sampling process ends up in the data, which ends up on the label. And so we want to avoid unethical sampling. Not taking samples that are commercially advantageous to you, sampling the best of the lot or cherry picking samples. Don't adulterate the samples prior to being sent to the laboratory. Again, the example of microwaving microbiology samples. And not following SOPs that are written. Taking shortcuts. The SOPs are written to incorporate all the steps that are appropriate, and taking shortcuts around them can lead to contamination, it can lead to all sorts of things. Falsifying data on paperwork, saying you send in one certain sample amount and actually sending in something else. All that information is typically tracked through there. So what happens if you were to have poor sampling? And what happens as far as the negative consequences go? Well, we've seen in industry recalls of product because of microbial contamination or pesticide contamination. We've seen look at from the commercial end of things, you misrepresent your product, which could be potentially harmful when causing public health concerns or issues, such as microbial contamination. You can have the wrong dosage. The dosage may be too weak for medical marijuana for usage, and which may not give those folks that need it enough pain relief, hunger stimulation, or seizure dissipation that they may need. And then, as far as immunocompromised people who are using medical marijuana, they may result in an infection because they're immunocompromised. The other thing is it gives you inconsistent results, inconsistent products, which then it leads to getting inconsistent usage and a wrong result or an unexpected result. So that comes back to the reputation of your company, of who you are as a company. And that's not something that we want to risk. So what does doing the right things do? It gives you analytical data that's meaningful to your facility, to your company, to your grow house, to your cultivation, to your manufacturing process. And you're able to use that data not only for product labels and releasing safe product, but also for your own manufacturing purposes and for your own growing purposes, and helps you understand what's going on within those facilities. Gives you accuracy on your labels, gives consistent product from batch to batch, it makes it predictable. So your customers know that they can come to your company and get the same product again and again and again. It's just like McDonald's or just like Starbucks. Everybody goes to Starbucks or McDonald's because you get the same product regardless of what city you're in, regardless of what store you're in. A Big Mac is a Big Mac, and a latte is a latte is a latte for Starbucks. So that's what you want. You want to be able to make sure that your customers know what they're getting and know they're getting a quality product. And that just improves the quality of your overall company as well. For those of you who don't know what an SOP is, so let's talk about those for a moment. An SOP is a standard operating procedure. So what is an SOP? An SOP is a procedure that lists all the steps necessary to complete a task. So in this task, we're talking about sampling. What are all the steps to take into account to take a sample of flour or of concentrates? You provide within the SOP enough detail that anybody who has a reasonable background within your company or within your firm or laboratory can pick up the SOP and complete the task with minimal training. These are living documents, and they will change and improve as you use them, and they should be seen as living documents. SOPs are never perfect, and they're never always complete. It's kind of like doing a lottery. It's never quite done. So why do you need one? We need an SOP because if you're doing the same task over and over and over again, and that task is a very quality-driven task, like sampling. You want to make sure that when you're sampling that you're doing things in a consistent, reliable, and unbiased manner. So having an SOP that outlines every single step that takes to do sampling within those same ways to make it consistent, to make it reliable, excuse me, will then allow you to have the sampling that you need and improve the quality of sampling and make it predictable for you as well. All this improves the quality of sampling. The data produced from the samples is representative of the final product being manufactured. The information being presented by your company is accurate, allowing for better decision making for your customers and the end users. And the data can indicate the value and worth of your product as well. Excuse me. What is the basic structure of an SOP? What does it need to have in it? So all the SOPs have a very similar structure, whether they're environmental laboratory SOPs or regular laboratory SOPs or the sampling SOPs we're talking about. That's have a purpose. Why are you writing the SOP? Let's have terms and acronyms and definitions so everybody understands what the SOP is about and the terms within it. You need to have equipment and supplies, what you need to know. The controls and frequency. How frequently are you sampling? What are the requirements for people who sample? What are the sample amounts being collected? What data do you collect with the samples? The procedure, how many samples you're actually collecting? What are the pre and post sampling things you need to do? You need to clean the area. Do you need to make sure your equipment is clean? When you're done sampling, clean the area. Make sure you clean your equipment. How do you sample? Where do you sample? What containers are you putting things into? How do you transport the samples from your facility to the laboratory? How are the containers? How are your samples stored so they get to the laboratory with minimal impact? And then what are the quality records and what are the safety concerns as well? One of the things you've seen as far as growing into the industry as well is safety. We always say that safety is first. Always be aware of what's going on and what you're doing and where appropriate safety apparel. PPE, personal protective equipment, safety glasses, gloves, lab coat, those things, if those are necessary. And then any additional equipment your facility may require. Hairnet, gloves, shoe covers, etc. If you're working in foods and creating edibles. So those are the things you need to make sure that you're wearing at all times. Let's talk about some sample collection, actually collecting the sample. There are different ways of doing things, and we want to go through and talk about some different strategies of looking at samples and collecting them in an appropriate manner. So how many samples do I take, and how much of the samples do I collect? Big questions, and those vary depending on what state you're in and what laboratories you're working with. Different states will tell you to collect different samples depending on your batch size. Different samples how much sample to take will vary upon the laboratories you're using or the state. Many states are coming out with minimum sample sizes. Colorado just came out with issued out a whole new minimum sample size for microbiology, or is getting ready to. So they're increasing that sample amount. So the minimum amount of sample that we encourage people to do is send in the laboratories. Is 2 to 3 analyses worth of sample. That way, the laboratory has enough sample. If something goes wrong in the laboratory, or you need to retest, they've got the sample there that they can move forward with. Though there are states like Maryland who is relying on the facilities to hold a sample collected at the same time at the facility, but they're kind of the outlier at the moment. Again, it varies by state, by batch size, by product. Let's talk about product for a minute. So a product may be, flour may be sampled differently than brownies, which will be sampled differently than shatter because of the sample size and the batch sizes that are there. And you should always check with the regulatory agency or the regulations to verify that you're pulling the right number of samples. This seems to be changing with every state, with every rule change. It just is, we're not quite there as far as standardizing things go. And as we move into having standardized methods, as we understand standardized processes, we'll see this starting to calm down and get more standardized ways of knowing how much sample to take, knowing what is a appropriate number of samples. We want to make sure everything is statistically valid and statistically representative of what's going on is with your samples as well, or with your batch size. So let's talk strategies. The most important strategy or the most important thing to have as far as sampling goes is aseptic technique, which is a specific set of practices and procedures so that you minimize the contamination of pathogens or cross-contamination when you're collecting samples. So it's taking the time, wearing gloves and the proper equipment and using the clean equipment to take samples. So how do you perform the technique? Well, you wear sterile or sanitized gloves. You use clean, rinsed, and alcohol-rinsed forceps. Clean, sterile, sanitized containers to collect samples into. The whirl bags, which people like to use a lot. Make sure that those are clean and sanitized whirl packs. Make sure they're coming out of the box clean and not been used before. Change your gloves and clean your equipment between sampling events or between sampling batches. When you're homogenizing samples, if you're allowed to do that, then make sure you wash and rinse and alcohol rinse all your equipment. Make sure that everything is clean as possible. Make sure when you're alcohol rinsing, make sure you use enough to remove all the oils and the pesticide residues that may collect. Oils and pesticides like to go stick together. They extract in the very same manner. And this isn't just for microbiology samples. These rules reduce all forms of cross-contamination, whether it be chemical or microbiological or any type of contamination. So you want to make sure you have good aseptic technique. So what are some examples of equipment list? So you want to review your equipment list before you begin and make sure you've got everything in-house. So develop a checklist for that equipment that you need. Always ensure that you've got enough inventory available before you start sampling. Do you have enough gloves, custody labels, security tape, sample containers, Ziploc bags, and make sure that everything is set up so the sampling event itself doesn't take as much time. This will make sure that you're more efficient and that you're not spending your time sampling and you can spend your time doing some other things that your company may want you to do. Make sure your scale and balance is calibrated by the state or has a current certificate available. Those are requirements from all the states that we've seen so far. And then store your sampling supplies separately and in a different location so that they're always kept segregated and clean and separate from what's going on within the facility. So let's take a look at some examples. So the example on the top examples on the right and left are good technique. They're being very careful. They're not touching the sample with their hands. They're touching with the forceps, and they're making sure that samples are put into the appropriate containers, whether it be a pack, a Ziploc bag, a pack, or a glass vial, depending on what's going on. And then the sample on the photograph on the bottom pretty much shows what you should not be doing. So although that's a picture of somebody doing trim, it's the same thing. It can be seen as far as sampling as well too. Not something you want to be doing with your bare hands, and not something you want to be doing in a very sloppy manner. So let's talk about sampling strategies for flour. So when you're looking at sampling in bins, the flour is stored in several different ways. It can be stored in bins and turkey bags. It can be stored in drying racks and then drying drawers. Excuse me. And what you want to be able to do is when you come in to take samples out of these containers, you want to be able to sample across the containers and then not only from the top, but throughout the container, from the top to bottom, and sample the top portion, the middle portion, and the bottom portion of each container, as well as going from the container crossways. So you can see the three arrows moving down through the container. You want to be able to sample on either end and make sure you're sampling within the middle as well. Kind of what the diagram on the left looks like. Sampling at the top of the bag, in the middle of the bag, or the bin or bag, and then at the bottom as well. So you want to make sure you're taking samples across or within the bin itself. And that gives you the best representation of what's going on within the bin, not just from grabbing guys from the top. Same thing with sampling turkey bags. You want to sample turkey bags in the same manner. You want to be able to sample within the bag, not only across the top, from side to side, but up and down through. So the top, middle portion, bottom portions as well. So you want to make sure you sample throughout all of those ways of looking at things. And that gives you the best way of seeing what's going on throughout the entire bag, not just at the top. Things may be going on within the bag itself that you may not see or know about. So it could be microbial growth, it could be mold, it could be molds and yeast growing there, it could be collection of a lot of other things. So that's what we encourage. The sampling rack as well. Again, for all tests except for maybe perhaps potency, you would want to follow a similar track. We'll talk about potency in a second. So you want to be able to sample plants at each of the different locations. At the ends of the drying rack and within the middle as well. And recently we talk about potency being a little bit different because potency you're trying to look at more of an average number of what's going on throughout the harvest. So you want to be able to sample across the plants as well. Now the issue comes down to is to understand what's going on as far as for potency. Is not to get the highest level or the highest number for marketing purposes. Not only sample the best buds for that, but to understand what's going on throughout the entire harvest batch. Not the most marketable, desirable data, perhaps for marketing purposes, but the most accurate data for your customer. And that gives you the best data that you want to move forward, and that's what you're selling to the public. Now, that being said, there are facilities and growing facilities out there who will selectively take buds and use those for the end product to be sold, and the rest might be sent off for extraction purposes. In that case, you have to take a look at what your operation is and how you're doing things, and make sure you're sampling appropriately. If you're only using the top buds for that purpose, then that's great. Then just sample those for THC levels. But if you're using the other buds for extraction, then you need to take a separate process. So you need to be able to document that in your SOPs as well, so that everybody knows what's going on and why. And that way, when you do get inspected, you can help explain, here's how we sample, and this is why we're doing it, because it fits into our business practices. You might want to sample at the plant level. You want to do similar. You want to test across the batch as well, but you also want to sample across the plant if using all the buds for purposes that way. And that way, you look at your sampling across the top, and the middle, and the bottom of the plant. And we don't do that because we know that cannabinoids and terpenes vary at the plant location as well. At the top of the plant, which is ironically at the bottom of the screen, we see that buds or cannabinoids are at the higher concentrations. And as you move upwards on the screen in the photograph, that those cannabinoids and terpenes will lessen as you move up toward the bottom of the plant. Drying racks and drawers. There are different types of these can be found in all different facilities. Every facility I've gone to has different ways of storing things, and whatever works for them is great. And they have their systems built around them. So we want to sample them in the same manner that we sample tubs and bags. Why? Because they've already been randomized as part of the process and of trimming and drying. So let's take a little bit closer look. So what we want to be able to do is look at the drawers and sample through the drawers from top to bottom, and then within the drawers sample around different locations within it, just to ensure that the samples collected represent what's going on not only within the entire rack, but within the drawer itself. Okay, concentrates. Concentrates are unique. It seems like that we have more types of concentrates than we do than anything else. So there are many different types of concentrates, as we all know. There's shatters of teeth, there's waxes, there's bubble hash, there's butters, there's liquids, there's oils and tinctures and other extracts. So this whole section first section we're going to talk about just the solid types of concentrates. So as we're looking at these, we want to be able to take representative samples around part of the concentrate itself. So we look at shatter as an example. And we want to be able to make sure we take from different locations and maybe perhaps different thicknesses. I've seen different papers talk about especially for shatter and some of the other solvent extracted concentrates, that the amount of residual solvents may vary in the thickness. I haven't seen anything definitive in that, but I've seen some papers written in that manner. So you want to be able to we would suggest that you take a cross section of, thin, thick, and medium areas as far as the sample goes. It takes a little more time, but it's going to be much more representative of what you've actually got going in there. And then the other part about it is that the amount that you're taking is going to be much less as far as, because you don't have as much sample there. I'm talking about 100 grams, maybe 200 grams for most of the shatters that are created. For some of the more thicker viscous samples that we'll be talking about in a minute, you're looking at probably 700, less than a kilogram of materials, especially for oils. So for oils and tinctures, we recommend this kind of this procedure, using a pipette or syringe to remove the sample amount, to be collected into an amber glass, autosempler vial or some other type of vial. Then those take aliquots at different depths of the oil or different depths of the extract. Make sure you're sampling, representative throughout the extract, and maybe at different locations perhaps as well. So the top, and the middle, and the third of the container, if you have that much room to be able to do that with. And then this sample should be homogenized before sending them to the laboratory. That way you're getting a homogeneous sample, and that should represent what's going on with the oil in the tincture. Don't worry about it, because we really haven't seen a whole lot of data yet talking about homogeneity and homogeneity of products within that, and that's kind of one of the other projects that we hopefully will be working on. So finished edibles and products, food products. Finished product is typically when we're looking at edibles, we look at a couple of different things. That everything is finished, ready for distribution. Everything is set up to go for being sold to the public. And different states require different amounts to be sampled. The number of samples that be taken, the amount to be sampled overall, the number of samples overall across a batch, whether homogeneity testing is required within the batch and within the product itself, and the types of analytes required. We're seeing more and more food-related requirements being added to edible products. They're seeing more of as food with marijuana being added to them, or cannabis products and oils added to them, as opposed to just being cannabis products. So we're seeing a lot of the food industry requirements being added to the testing requirements as well. One laboratory that we work with actually is working with manufacturers and the first thing they do is test their base product prior to adding any type of oils or concentrates to it. And so what we want to be able to say is, how do you do this? How do you handle this? Looking at it. Well, if you're required to take 10% of your samples, then you would go ahead and say, great, there would be every 10th sample that you would take. And the example here, if you have a harvest batch of 300 individually packaged cookies, and your minimum sample amount is 29, you take the total number of samples that you have, divided by the number of samples that you're required to take, and then look at, which would be in this case around just over 10, and then round to the nearest whole number, in this case 10, and then take every 10th sample. Or take every 10th sample until you've captured 29 samples. And that's how you do that in a randomized fashion. And that gives you the best solution as far as statistical representation of what's going on. The best practice is to split the production batch into thirds and randomly sample from each production as you're creating it. That isn't always happened, isn't always you're able to do that, and this is why we came up with the first approach as well. The sample collection then must be randomly from the entire batch, or harvest batch, or from the production batch. And the samplers reach the end of that batch, and you're still running and creating samples. You start again at the same process, and move forward. Transportation to the laboratory. Since most states, we don't have any interstate transportation yet, all the transportation to the laboratory for the samples happens within a fairly short time frame. One of the things you want to ensure when you're transporting samples is that nothing affects the samples during that time frame. So the time that they're sampled, the time that they actually reach the laboratory, nothing happens to the sample that changes the sample. So for example, if it's a hot summer day, you might want to have to worry about heat effects. Cars make great incubators for microbes. And you don't want any microbial contamination growing in the sample while it's being transported that isn't actually wasn't there at the beginning of your facility. Again, and cross contamination with other samples. You want your samples to be exposed to others during that time frame either. So how you package and how you send things to them, and the amount of time it takes to transport things, and how you maintain your sample integrity is important to the end process. You don't want anything to happen to those samples. You just work so hard to collect and work so diligently to collect. You want to make sure that those things are packaged appropriately, perhaps in a cooler, make sure that they're kept cool, so to keep down the microbial growth, so it maintains the growth of what it was when you packaged it, and keep everything else fine, and make sure that nothing else happens to the samples moving forward. So those are the things to take into account when you talk about transporting samples to the laboratory. So what happens at the laboratory? Samples are received. They're weighed and measured to make sure they're compliant. Then they're subdivided into different samples for analysis, depending on what they're being analyzed for, whether it be for potency, terpenes, residual solvents, microbiological, mycotoxins, metals, or pesticides. The laboratory will then take your sampling, and then break it down into smaller samples, which means that's even more critical as to why your samples have to be representative of what's growing in the batch. That way, the subsampling that happens in the laboratory, again, continues to represent what's actually happening within your product or your batch or your harvest. And that's our talk for today. So we're looking forward to entertaining some questions.
Thank you, Shawn, for that informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question drop-down box located on the far left of your presentation window. Type your question into the box that appears on your screen and click on the Send button. We'll answer as many of your questions as we have time for. How much sample should I collect?
The sample amount depends on the state and the laboratory that you're working with. I really encourage people to understand what their state requirements are and their laboratory requirements are. And the reason we do that is that many states are starting to set minimum sample requirements, such as Colorado. And the laboratories each have their own different sample amounts that they require for the different analyses. We also encourage people to collect enough sample for more than one analysis, for 2 or 3 analyses, depending on what the analysis is. This allows that there is enough sample at the laboratory to go ahead and do a reanalysis if it's necessary, whether something happens at the laboratory or the results come back and you need a reanalysis. Then that laboratory can either perform the reanalysis or send that to a separate facility if your state allows that for reanalysis. So overall, we encourage people to understand what their state regulatory requirements are and to work with their laboratories to understand how much sample is actually required per test. And that'll help you narrow down how much sample to send, and that makes sure you're not sending too much, but also you're sending enough to make sure you've got enough insurance that you can get your sample analyses, if it has to be reanalyzed, done in a timely manner so you can move forward with getting that product released.
Thank you. The next one is, do I need a standard operating procedure and SOP for sampling?
We would encourage everyone to have SOPs for sampling because that is necessary to make sure that your sampling is consistent, that everybody's doing the same thing within your facility, within your company, if you're a sampling company or a laboratory, or if you're a facility itself. And then that way you know from person to person that sampling is being done in a consistent manner. That also ensures that the state, when they start looking at regulatory information, know that sampling is being done in a consistent manner as well. And it makes the data more meaningful that when they're looking at things for public health concerns. But it also makes sure that you get a consistent product back from your laboratory. And consistent product back from your laboratory is consistent data that gives you accurate and accountable information for your product. And that's really what you're looking for your labeling purposes and whether you release product or not.
The next one is, should I change gloves between each batch?
Oh, absolutely change gloves between each batch. Change gloves between each batch, clean your equipment between each batch, and make sure everything is sanitary from batch to batch. Because that'll help reduce cross-contamination, whether it be microbial cross-contamination or whether it be chemical cross-contamination for pesticides or other cannabinoids. So we really encourage everybody to change your gloves and clean your equipment between batches.
Should I clean the sampling equipment between each batch?
Absolutely. Yes, please.
Your next one is, if I'm buying concentrate, do I have to test the concentrate before I use it in making a product?
That question is, from a business aspect, I would say yes. You'd always want to know what your product is coming in to your process, so you know what the concentration of cannabinoids are. You can really either rely on the people giving you that information who manufacture the concentrates, or you can do it your own testing. We encourage you to do your own testing until you understand, make sure that you have a real good, comfortable relationship with that manufacturer. It also depends on what the requirements are for the state. In some states, they do require testing between anytime a product changes hands. So if you're buying a concentrate for manufacturing purposes, the state may require testing before you get it, whether it's a final product or not. That doesn't matter. The state wants to know between the two parties that there's testing done before coming in. So we encourage, from a business perspective, yes, that you know what's coming in, but from a regulatory perspective, that you understand that as well, in case there's further testing that's required.
Well, thank you. And we have time for one more question. If I'm making concentrate, do I have to test the concentrate before I use it in making a product?
Again, we would recommend that you do so. It is not recommended that you go without it. The type of testing that you would want to do would be to understand what's going on with that concentrate, perhaps potency testing, and then do microbiological and potency testing at the end to make sure that the products that you're producing don't contain microbial contamination. But understanding the cannabinoid level going into your product manufacturing is important so that you know your dosage is correct and your recipe and your formulations are correct.
Well, I would like to once again thank Shawn Kassner for his presentation. I would also like to thank LabRoots for making today's educational webcast possible. Before we go, I want to let everyone know that today's webcast will be available for on-demand viewing through June 29th, 2018. You will receive an email from LabRoots letting you know when this webcast is available for replay. Please share that announcement with your colleagues who may have missed today's live event. That's all for now. Thank you for joining us. We hope to see you again soon. Bye.